Hello everyone, welcome to one more session of the Cloud and Lunch and Learn. I have here with me today Andy Cutler that to talk about build a DW dimensional model also. Okay, before we jump and talk with Andy, I would like to for you to scan this QR code and get a free access to the resource that we just get for you from Microsoft. And please provide your feedback, your insights that would be really much appreciated. I would like to say thank you again from Microsoft as our sponsor. And Andy, you there?
Hello.
Hello, Andy. How are you?
I'm very well, thank you.
Good. Look, Andy, tell me a little bit about yourself before we jump into this amazing session, okay?
Yeah, sure. So my name's Andy Cutler. So I'm an independent consultant and contractor. I primarily work with the Azure Data Platform, so Synapse Analytics, Data Factory, Power BI. I've been using Microsoft, the BI stack for well over 15, 16 years, starting with the traditional SSIS SSAS stack, and then slowly transitioning, from around 2016 into the Azure Data Platform. So that's why I'm here now talking about Synapse Analytics.
Oh, that's great. Look like you have an amazing experience, and I'm really looking forward for you what you have to share, to collect insights, and so on. I'd like to highlight to the audience, if at any point you have any questions that maybe come up, just type to the chat. I'll be monitoring all the social medias, and I'll come back. I will just talk with Andy to be able to answer this. Okay? And the floor is yours. If you want to share your screen and proceed, it's fine.
I will share.
Let me add here. Okay, here we go.
So you let me know when you can see my screen.
Yeah, we can see it. Andy, the floor is yours.
Thank you very much. Well, firstly, thank you very much, Victor. And thank you very much, Lisa, for inviting me on to talk about building a data warehouse dimensional model using the Serverless SQL Pools engine within Synapse Analytics. Bit of a mouthful, that title. Do appreciate that. We are going to break it down step by step as we go through this session. I'll just hide that. So a little bit about me. I'm an independent consultant and contractor working with the Azure Data Platform. If you scan the QR code, it'll take you to my Twitter. If you like to connect, and we'll just carry on the Synapse Analytics conversation there. There's my LinkedIn details and my website that I blog at. So in this session, really, what are we looking to get out of this session? So we're going to talk a little bit about what Synapse Analytics is, the various services that are available within Synapse. Then we'll drill into the Serverless SQL Pools service itself. What do we use it for, or what can we use it for? We'll look at data warehousing options, and then we'll start to look at how we actually use Serverless SQL itself. We'll look at creating the Synapse database environment in Serverless. Then we'll look at connecting to our source data. And then we'll look at, well, how can we use Serverless to actually take that data and transform it into a more analytical model for us, into dimension and into facts. And we'll look at reading that dimensional data as well. And we'll have a few points around Serverless SQL Pools considerations. So with Serverless Analytics, or with Synapse Analytics itself, it's actually a set of services. We've got 3 pools engines in there. We've got dedicated, serverless, and Spark. Now, some of you may have already used dedicated SQL pools for a few years. They used to be known as the SQL Data Warehouse Service. This is where you are actually importing data into SQL database, into the dedicated SQL Pools engine itself. Serverless, on the other hand, it's a SQL-based service. It does not contain any data itself. it allows us to connect to data stored in Azure Storage, in Data Lake Gen1 and Gen2, and also Cosmos DB. And with Spark Pools, we can actually use, I think we're up to Spark 3.1 is in preview, and we can bring our Python and our Scala workloads into Synapse Analytics. We also have pipelines, which is Data Factory. And we've got Power BI integration in that as well. So diving into Serverless SQL Pools themselves, it's a SQL-based service. That's the crux of Serverless SQL Pools. It's a SQL-based engine that's inbuilt within Synapse Analytics. So when you create a Synapse Analytics workspace, you will get Serverless SQL Pools by default. And it allows us to not only read, but actually write data from Azure Storage using delimited files, Parquet files, and nested data types like JSON, and reading from Cosmos DB. Important thing to note is that no data is stored within the Serverless SQL Pools engine itself. It is an engine. If you'd like to read up more about the engine, it's called the Polaris Engine, and I can tweet a link out to the paper. We can write data back to Azure Storage, but we have familiar objects available to us within a Serverless SQL Pools database. We can create tables, external tables that point to our data. We can create views over that data. We can create databases to house these objects. We can create stored procedures, and we've got access to some DMVs to help us administrate and manage Serverless SQL Pools. One thing to note is that the cost model of Serverless SQL Pools is all around how much data you're processing. It's not the amount of compute. It isn't the length of time that the compute is running. It's how much data you're processing. That's both for reading and for writing. And we're currently around $5 per 1 terabyte of data that you're processing. Now, Azure and Synapse Analytics isn't the only vendor working in this space. I would like to call out Google BigQuery, Amazon Redshift, especially Amazon Redshift Spectrum, and Snowflake. Okay, competition's good, right? Competition is good because everyone is trying to get the best features out of their offering. Now, we're going to dive into the Serverless SQL Pools scenario itself. And really, I was interested in this service in terms of, can I build a data warehouse using Serverless SQL Pools as the processing engine? And I said, well, why do I want to do this? Well, firstly, I'd like to leverage my existing SQL skills. I am, I'll be honest, not much of a Python developer, nor am I a Scala developer, but I'd like to use my SQL skills in a big data processing engine. Perhaps I have a lot of data stored in my data lake that I would like to take advantage of without having to pull that data into a proprietary database system. But also I'm interested in looking at this data lakehouse concept, bringing the relational constructs to data in a data lake. Now, in Microsoft's official documentation, they do actually state 3 use cases for Serverless SQL Pools. We've got data exploration, ad hoc data exploration, in which you can connect to data in a data lake and write SQL to process that data. You might be crunching and aggregating a whole bunch of event and activity data stored in a data lake. The concept of a logical data warehouse, in which we are casting structure over data without moving that data. Now, we'll explore that option later on, or how we advance that option later on. And lastly, data transformation. So because Serverless SQL Pools is based on SQL, we've got the full power of the SQL syntax. Some functionality isn't available, but we've got SQL to help us process data as well. Now, when we're looking at setting up the Synapse environment, we can start by creating a serverless database that can house our schemas, our security, our views, all our objects. The first thing I'll do is create a database, and I can create schemas just like I would in a dedicated SQL pool or Azure SQL database or SQL Server. Now, for this demonstration, we're going to be using Active Directory authentication to pass through from Synapse Studio when I'm writing queries to the serverless service down to the data lake. There are multiple security mechanisms in place. We're using Active Directory. Then I create an external data source. I'm telling Serverless SQL, well, where's my data lake? So in Azure Storage, you have various URLs that can be used to access the various services. One of those is the DFS protocol, which is the data lake URL. I need to tell Serverless, well, what types of data am I processing? How is my delimited text actually being delimited? So in this example here, my field terminator is a pipe, and the first row of data is row 2. Now, when we're creating objects within Serverless SQL Pools, we've got two choices in how we cast structure over data in the data lake. We have external tables and we have views. Now, there are differences between these two objects and their functionality. So when you're creating an external table, you must define the schema. You must define columns and their data types. And you're not able to do something called partition pruning. So if your data lake has a folder structure, such as year, month, day, where you're partitioning data, yes, you can select that data. Yes, you can filter on that data, but you won't be able to specifically identify source folders. Whereas in views, we don't need to define a schema. We can select all if we want to. But more importantly, there's a function called file path in Serverless SQL Pools in which we can expose the source folder hierarchy, and we're able to partition prune by filtering. The rest of this session will be using views to cast structure over the data, and we'll be using external tables to write data. So for our initial load, what we want to do is we want to create some views over data that's in our data lake. So we're going to create a view. As you can see, it's using CSV files. We've specified the data source, which is the data lake URL, and a folder in which we've got our CSVs stored in. I'll do that for the fact data as well. Now, if you note within that syntax is we have a file path option. And within the bulk command, we have asterisks or wildcards. Those file path locations point to those wildcards. So file path 1 points to the order year folder, file path 2 points to the order month, etc. Now, when we're looking at the dimensional model, it's a methodology that has existed for many years. And we are looking to describe our data in two ways. We are looking to either create measurements or facts, things that we want to measure, and dimensions, the way in which we want to measure something. So we can think of dimensions as the reference data, the report labels, and we can look at fact tables as the measurements themselves. Now, the reason why I'm marrying these two together is that Microsoft have a best practices document for serverless SQL pools. It tells you about co-locating storage accounts, optimizing data types. The one thing that did catch my eye is it states use integer-based data types if possible. So your sort, your join, and your group by operations. There's a screenshot from the best practices document itself. And where have I seen integers before? Surrogate keys in data warehousing. Okay, so just to pause on this for a minute, even if you were not created a dimensional structure, it still is of benefit to join your data in serverless SQL pools on integer, because if you're joining on character data, the amount of data may actually be larger than using integer-based joins. So that's an important consideration there. So when we're looking at the initial dimension loading, we are going to use the create external table syntax, but we're using CTAS, create external table as select. And we're going to create a SQL query. We're going to generate a row number, a surrogate key. We're going to join on our source views, because essentially we are denormalizing our data now, but we're saving that data back to the data lake in Parquet file format. Now, Parquet is a column store compressed file format that's very good for data warehousing and analytical workloads. Ultimately, we're writing that data out as Parquet, and we're using a row number as a surrogate key. So for the fact loading, we're following the same process. Now, our source data is in a folder structure, and we'll come on to this when we go through the demonstration. Okay, but ultimately we are loading all of that data from our sales order lines and sales order views, and we are saving and pushing that data out as Parquet to the data lake. Ultimately, when we're selecting from the data, we don't actually want to use the external table. It's important to note that in this process, I'm using the create external table as select syntax purely to write the data out using serverless SQL. Actually, I can drop that table. The data itself from the data lake will not be dropped, and I can create views on top of that data. So now I'm creating a view to select my dim stock item dimension purely from that processed Parquet file. And I can create aggregate queries over that data by joining my fact data together with my dimension data. So with the considerations, we're writing the data based on the amount of data that's being processed, not the time or the processing power itself. So there's no compute time or compute tier costings. It's purely amount of data processed. There's no caching of the data retrieved. So if a query is performing the exact same operation and the data hasn't changed, there won't be any caching. It will add to your data processed again. And currently the data is immutable. So you can write data into your data lake, but you're not able to update that data. You can with Delta, but it's outside the scope of this session. So now I'd like to jump into a live demo and go through the process of creating these objects and writing the data out so you can see what's happening. It's the one thing I would just like to do. Let's change that. I think it was jumping between sizes there. Okay. So we've created a database already, Lunch and Learn, and I'm going to create an external data source to my Data Lake account. Specify the URL. I'm going to create a file format for Parquet. I'm not going to create a file format for CSV purely because I'm using views to connect to that CSV data. I'm going to create my schemas to store my objects in. I will run an alter database command to support UTF-8 source data. And the last thing I'll do is I'll just run security and this environment will be taken down after this demonstration, by the way. And my user identity is my own Active Directory account that will be used to pass through all the way down to the data lake. So after we've set our objects up, we will look at our views. Now, the syntax for our views is we're going to create a view and we use the open row set command. We point to the folder location that our CSV data is in. We specify the URL, i.e. the data source, to our data lake. The format, parser version 2.0, which is a faster CSV or delimited parser engine. We've got a header row and a field terminator. So I've got stock items, colors, and package types. And I've got my sales orders and my sales order lines data. And as you can see, I've got this file path function that I'm using to expose the hierarchical folder structure. If I run those views, and if we have a look at our database, okay, we don't seem to have our lunch and learn there. That's okay. We'll go ahead and create our dimensions. I'm going to skip back to the data lake just to show you the source data that those views are pulling from. So we've got our warehouse colors, our package types, and our stock items as CSV files. And we've got our sales data as well, which is partitioned by year, month, and day. I'm now going to run the create external table command as selecting from those views. I specify the location that I want that Parquet file to be stored in, or data to be stored in. So I'll run that. And if we jump back to our data lake, we can see that we have a new folder with our data inside. And we'll create a view over that data, which is pointing to the Parquet file. And lastly, we'll create a dim date dimension that is just based on a CSV stored in the data lake as well. So after that, we'll just do a select all from our view just to see that data is being pulled through and it's being denormalized. So we have our color name and package type. Then we'd like to use the sales data that we have plus the dimensions we've created to create a fact. Again, I'm going to use the create external table as select syntax, joining to my dimension to get my surrogate key. If I run this process, I'm in effect getting all of the data from my sales order. And the last thing I'll do is create my view over that data. If I go back to the data lake, we can see that we now got a facts folder. If we go into that facts folder and into fact sales, we have our Parquet file available. Now, just to note that in our source folder, so if we go back up to our top level folder and look in our sales order, we actually have three folders here, because our data is being exported by day. It could even be by hour, by minute, but we have a folder structure there. Now, this is an important consideration when you're dealing with a large amount of data. Usually, you'll want to partition your data in the data lake by a hierarchical folder structure. However, what we've done is simply loaded it into one destination folder. Now, dependent on how much source data there was available would actually depend on how many Parquet files would be written out. So Serverless SQL Pools doesn't give you any options in terms of how many files or how many rows per file. I do actually have a blog which goes through different levels of rows being written out to a data lake via serverless, and how many Parquet files and how many rows per Parquet file is written out. Links are at the end of the session. Okay, so now that we've created our fact data, we can now use these tables or use these views like regular views that we were selecting data from. So now we've got our weekday name, we've got our color, and we've aggregated the total quantity. That's fine. However, going back to what I was saying is we loaded all of that data from separate folders into one folder. What we can do is we can break that down so that we can load a day's worth or a folder's worth of data from the source into a destination folder structure that matches the same pattern. Now, one of the supported objects that we have within SQL Pools, just going to collapse that, are stored procedures. So you can add any sort of logic that you would like to do processing. As long as the syntax is supported by serverless, you can create stored procedures. What we're doing here is we're using the external table purely as a loading table. So when we write the select statement out using the external table, we can drop that external table and create it again, pointing to a different location. And I have some dynamic SQL here that is allowing me to parameterize that location and also the source data. So I'm going to select a specific day's worth of data from a source folder, and I'm going to use that to write it out to the same folder structure. So now if I run my stored procedure for my 3 dates, I've got 3 days worth of data in my source system just for demonstration purposes. Let's create that stored procedure. And if we go back, we're going to run that procedure. We'll get the first one back. We'll go back into our data lake, into our new conformed folder. And as we can see, we've got our fact sales, but we've now got a year, month, and day structure, which means I can go in I can run that for the second day, and I'll run it for the third day. If I come back in and refresh, we'll see I have a folder structure that represents what I would like the Parquet data to be stored in. And I'll create a view. I'm going to bring in the file paths of that data, and I'm also going to bring in the file name as well, because I'd like to show the metadata attached to this data from the data lake. So if I create this view, and I'm going to do a regular select from that view to show that we've got our date, we've got our colors, and we've got our total quantity. But I'm going to show the metadata that's associated with that. Okay, so I've got a select query here that's selecting the year, the month, the date from the view. And if we go back up to our view, we'll see that I've essentially aliased the file path location 1 as the year, the file path location 2 as the month, and the file path location 3 as the date. And if we look at this bulk statement here, we have 1, 2, and 3. So now if I select this data, I'm going to bring this up, and we can see that we have, if I just scroll down, so we have the date from inside the files themselves, and we can see that we've got the 15th of April stored in the 15th of April folder structure. If we go to the 16th, we've got the 16th. And if we have the 17th, we've got the 17th. And you can also see the source file name that the data comes from itself. So that's just exposed with the file path and the file name functionality. So what I would like to do is one last check to see if my lunch and learn, but I won't. So what I'll do is I'll open up another database and just show the resources that have been created. So we've got external connection to our data lake, and we've got our file format. We've got our external tables, just our transient tables we're using to load data. We have our schemas, including the custom schemas that we created to store our views and our external tables. And we have our views. And if we expand our views, we've got our column definitions. Okay. Now, we can use SQL Server Management Studio. We can use Azure Data Studio to connect. We don't have to log in and use the Synapse Analytics Studio. So we have other SQL tools available to be able to connect and use serverless SQL pools.
Hey, Andy.
Hello.
Sorry to interrupt you. Yeah. So we have a question from Marshall. I don't think you're seeing this on the screen.
Oh yeah, I can see the question now from Mark. Yeah.
Yeah. So
have you tried the following, writing data out? If you had 1,000 rows in Synapse, when writing to a file, do a select top 2 million, sorry, 1 million rows in Synapse. When writing to a file, do a select top 2 million, any number that is greater than the known data row count. I haven't, Mark. I haven't. We could do it though. So it works with normal Synapse. We're not tried it with on demand. If the top number is greater, then you should get a single file. That's great. We won't do it here, but what I want to do is I want to create a new script. I have seen some interesting behavior when using top to write data out. Sometimes if I did have a select and I was writing data out and I knew that it was 1,000,000 rows and I selected 1,000,000 rows, yes, it would create a single file. Whereas if I just let it do its own thing, it could create several files. It's a great one though. So what I'll do is I will add a script to say top. I'll say test select top where top is greater than known rows. Yeah, I'd love to test that out. So I'm going to test that out and probably tweet that out. Okay, what I'd like to then go back to before we go back to the slides and finish up the session is this concept of data processed. Okay, so when you're using serverless SQL pools, this is how you're being charged. Okay, so how do you find out how much you're using? So we've got monitor available within Synapse. And if we've got our SQL pools, we've got our built-in. This always exists. This always exists. I mean, you can see I've got a dedicated SQL pool there. So I could have any number of these, but I've got one serverless built in. So if I click on that, okay, we get some stats about the data that we're processing. So as we can see, I've processed 53.51 meg. I can change that for the last 30 days and we can see what's happening in this particular instance of Synapse Analytics. And we've got our success and failed requests available here. Now, if we go and click on SQL Requests itself, we can see the requests that are being sent down to serverless SQL pools. This is also really good for when you're connecting external tools such as Power BI. So I have a logical data warehouse blog series, about 4 posts. The last one is about connecting Power BI. Ultimately, you'd love to visualize this data. So there are some caveats in terms of connecting to serverless and partition pruning to reduce the amount of data that you're processing to return your query results. However, when you're running your SQL statements, when you're analyzing your workloads, you can see the data processed metric here. Now, you're going to see a whole lot of 10 meg processed here. I'm not processing that much in this demo. Even if I was only processing 1 meg, the minimum data processed per query is 10 meg. So that's an important consideration. But as we can see here, maybe if I go back the last 30 days and scroll down, there we go. We can start seeing some juicier numbers. So we've got 2 GB here for a select, 6.43 GB here. So ultimately, you add all of this up. That's how much you're being charged. I do have on GitHub, and again, I'll probably tweet the link out, a very embryonic repo with serverless SQL tools. So there is a select statement that you can run to get all this data out of serverless SQL using DMVs. Now, what happens if you would like to set some limits on this data processed? We can do that. So the built-in, we've got this tiny little icon here, which cost control. We're able to control this using stored procedures as well. So you can execute stored procedure, a system stored procedure rather, and update this cost control. But what we're telling Azure is if on any given day, 4 terabytes of data have been processed, don't let any more queries be executed. On a weekly limit, we have 8, and a monthly limit, we have 16. So for example, my particular account, 16 times £3.50 will give you know, the total amount that I am prepared to spend on serverless every month. I just want to try one more on the database to see whether Lunch and Learn appears. No, that's absolutely fine. Oh, Lunch and Learn down the bottom there. There we go. So there's our external resources and our views. Okay, and you can see I've created many databases here. So you can have a lot of databases in your Serverless SQL Pools service. Okay, so we'll jump back to the slides just to finish off. Oops, here we go. Okay, so I have a blog, serverlesssql.com, where I've got various blogs on using the Serverless SQL Pools service itself. So there's a getting started, which will go through actually creating a Synapse Analytics workspace itself, logging into Studio and starting to use the service. There's a 4-part blog series in which I essentially go through the process that this session's gone through. We go into a little bit more detail. There's GitHub repositories for SQL, so you've got you can download the code to do that. We look at slowly changing dimensions. Now we are pushing Serverless SQL Pools a little bit here in its inbuilt functionality, but I offer a solution in which, if you'd like to track changes to source data over time using serverless and writing that data back to the data lake as Parquet, that's included. And we're also connecting Power BI to our views in our serverless SQL Pools database. That one's the most interesting one, I would say, because it goes through the process of how do we partition prune. If we're building a report and we've got date filters, for example, how do they get pushed down to Serverless SQL Pools, and how do we initiate this file path function successfully to reduce the amount of data that is being processed? So resources for further reading. There's the official documentation for Synapse Analytics. There's the Lakehouse. Yes, it's Databricks, but it's a definition of the data lakehouse itself. A little bit about dimensional modeling and the Parquet file format itself. And I will leave it back on the references and further reading. So we'll thank you very much for listening. I hope it's been useful. And if there's questions, we can dive in. Feel free to ask anything. If I don't know it, I'll take it away and I'll research it and I'll get back to you.
Amazing.
Such as the top 1 million, top 2 million. I'm pretty interested to see what happens with the behavior there.
There's one question here, Andy. Let me show for you. So does that trick at top avoid Synapse choosing the Parquet size and give you the more control?
We'll find out, John. We will find out. Definitely when I have tested using top before, I was sure that it reduced the number of files that were being created. I ran a query or a create external table as select on a lot of data, so quite a few gig of data that was in separate date folders. When I wrote that out, when I looked at that resultant folder, there were a lot of Parquet files. It almost looked as if it was created a Parquet file for every source folder, which is a bit funny because I wouldn't think that serverless would essentially be having a one-to-one relationship with a source folder and a Parquet file. When I was using top to write data out to see what the file sizes were with a known row count, I'm sure it did reduce the number of Parquet files that were created. I'm pretty sure. I'd love to test it now, but I'm not 100% that I've got the connection to the files that I would need to do that. But I'll do it. I'll do it after this, I think.
Yeah, Great, Andy. I think so far was really an amazing session. Again, for me, it was a masterclass about how to use the serverless. I'd like to thank you, John and Mark, for the question. That's amazing as well. Uh, Let
Yes,
me
thank
just
you.
switch it just a little bit here. So I'd like to thank you again from Microsoft to provide for us the sponsor for this session. I sent a couple links through the chat and ask the guys to claim the vouchers for the certifications. You'll be available there. And it's important that the vouchers will expire this month. So go there, get your voucher, and already submit for the exams. Uh, I have some comments here for John saying thank you for a wonderful session, for to you to see. Oh, that's great. Good feedback, Andy. Was brilliant for sure.
Yeah, John, by all means, that blog series, it was as we went along. So it was sort of exploring what serverless can do on its own. What I'd like to do next is bring in pipelines, okay? Because we don't have too much control over how we're writing that data out. Maybe the top could help us, but ultimately with pipelines, if we did need to transform that source data, if it was just a little bit too inefficient to be reading lots of CSV files, and we did want to transform that into Parquet for then serverless to read ad hoc, then pipelines would probably be a good way to go, because then we can partition our data. We've got a lot more control over what we're doing when we're writing that data out.
Yeah.
So Mark, yeah, so compute nodes. So yeah, with dedicated, that may be the case. But obviously with serverless, there is no, well, I guess we don't know how many nodes the Polaris Engine is using for any given level of compute. It's an interesting question to ask, though.
Yeah, so have some really good feedback, Sandy. Again, was really great session. Thank you so much for the participation. And guys, feel free to reach out to Andy and his social network. And for sure, he'll giving a lot of insights. And I just trust and believe in his blog post about Synapse is really cool. I think John's just skipping here. So John's mentioned I never met a CSV pipeline that service provider didn't change the schema. Looking forward to those articles. Yes, nice one. That's great, guys. That's great. That's great. Good participation, guys. Abstract anyway. Yes. I'm from Microsoft. I can say sometimes this really abstract.
We love control. We like to know what we're doing with our data engineering pipelines.
Yeah, exactly.
But yeah, I don't know. I'm going to have a little look to see that exam voucher. But if anyone was interested in the Synapse Analytics route of certification, then the DP 203, which is the new single data engineering certification, is really good. It covers data lakes, it covers data factory, Synapse, dedicated, serverless, and Power BI integration. So it's really good. It's really good certification.
Oh yeah, I didn't know about this because I certified both in GP 200 and 201. And are you saying that the GP 203 is more heavy in terms of Synapse?
Well, it's a good question. I mean, it covered lots of different aspects. It had streaming analytics, event hubs and streaming analytics,
Okay.
Data lakes, and setting up folder structures and folder patterns, data factory, so configuring sources and destinations, and then yes, the things like table distribution in dedicated SQL pools, hash distribution, replicator distribution, that kind of thing. And then with serverless, the objects required to connect to and read data, so creating external data sources and file formats.
Yeah, that makes sense. Looking forward to try these exams as well. So I don't see any more questions here. Andy, one more time, amazing session. Thank you so much for providing this for us. If you have more sessions, Andy, just bring to us. We're looking forward to having more here.
Well, there is. We're going to look at bringing in a bit of Spark, a little bit of Spark, but
Yeah.
the plugging in of business intelligence tools is the big thing, because, as I said, this whole concept of partition pruning, it's what you need to be doing. And there are some considerations on that which I'd like to talk about.
Yeah, for sure. Okay, Andy, thank you so much. And that's it for today. And see you next time. Okay.
Thanks, everyone. Take care.
Thank you, Andy. Bye-bye.
Bye-bye.